All right, now that you know how to determine the number of significant figures in any measured value, and then how to round numbers given probably calculations from beforehand, you need to actually know how to do the calculations and report the proper number of significant figures. There are two basic types of mathematical processes that we will do in this class. We'll have addition and subtraction as one, and then multiplication and division as the other. The addition and subtraction, those are basically the same type of operator. They're just in the opposite sense. By adding something or subtracting, they mean the same thing, but in opposite cases. Just like multiplying two things together and dividing two things together are kind of the opposite. So addition and subtraction, they have the same rules. We're going to use these much less commonly than we will use multiplication and division, though. And so the rule for these addition and subtraction calculations is that the answer to a simple addition or subtraction problem or a step in a series of calculations is to be rounded to the same number of decimal places, not the number of digits in total, but the same number of decimal places as the measurement with the fewest number of decimal places. So for example, we have 12.52 meters plus 349.0 meters plus 8.24 meters. And so if we add those up, 12.52 meters, 349.0 meters, and 8.24 meters, you can see that you get 6, 7, here's your decimal, 2 plus 9 is 11, plus 8 is 19. Now you have 1 plus 1 plus 4 is a 6, and you get the 3 there, and since they're all measured in meters, the answer is in meters. Now this is what you would get in a mathematics class, 369.76 meters. But the rule states that you have to do an addition or subtraction calculation and report the answer to the number of decimal places that the number is used to make that number in the calculation with the fewest number of decimal places. So what we have are 12.52, it has 2. We've got 349.0, which has the 1 decimal place, and we have 8.24, which has 2. So the answer has to be to 1 decimal place, because 349.0 only has 1 decimal place. So our answer is really 369.8 meters. All right, now rules for multiplication and division. There's actually 2 rules here. The answer to a problem or step in a series of calculations is to be rounded to the same number of significant figures as the measurement with the fewest number of total significant figures, which means we include the entire number, not just the decimal. The position of the decimal point has nothing to do with the rounding process when multiplying and dividing measurements. So, as we can see here, I have 7.55 meters times 0.34 meters, 2.10 meters times 0.70 meters, and 2.4526 meters divided by 8.4. Alright, so the first problem here is 7.55 meters times 0.34 meters. And the first thing that I would do is to write it up and down in the multiplication. So you have it written like that. But even that, to me, I would do it that way, but what you want to remember here is that the meters, the units, are important. That is really what it comes down to in chemistry is the most important thing to always be thinking about. The numbers are actually irrelevant. It's really the units that when you're learning this material, you have to think first and foremost about the units. And we'll see that not so much here in this chapter, but later on throughout the semester. So I would rewrite this as 7.55 times 0.34. And then over here, meters times meters. Now, anytime you multiply something by itself, in this case, meters times meters, you're going to get that number squared. If it's not a number, if it's a letter, you just have it squared. Now we can do the multiplication of the numbers. 5 times 4 is 20. Carry the 2. 5 times 4 is 20. Plus 2 is 22. Carry the 2. 7 times 4 is 28. Plus 2 is 30. Bring down a 0. 5 times 3 is 15. Carry the 1. 5 times 3 is 15. Plus 1 is 16. Carry the 1. 7 times 3 is 21. Plus 1 is 23. Or 22. Now add them up. You get 0, 7, 6, 5, and 2. Now here you have to count how many decimal places there are in the number. There's 1, 2, 3, 4 total. So you go backwards from here 4 times. 1, 2, 3, 4. So 2.5670 square meters. That's what you would get in your calculator. But you have to think about how many significant figures each number in the calculation had. This has 5 significant figures, but 0.34 only had 2. So in reality, this is 2.6 square meters. And that is the correct answer, 2.6. If we look at the calculated number, since it's supposed to be 2 significant figures, you've got 1 and 2, and then you have a 6 there, which makes the 5 round up to a 6. Problem 2 here is 2.10 times 0.70 meters. So again, I'm going to write this up and down. And so you have 2.10 meters times 0.70 meters. And I'm not going to write the meters to the side, but 0 times 0 is 0, 1 times 0 is 0, 2 times 0 is 0, bring down a 0, 0 times 7 is 0, 1 times 7 is 7, 2 times 7 is 14. Add everything up, 0, 0, 7, 4, 1. There are 4 decimal places total in the numbers multiply, so we move the decimal place 4 times. 1, 2, 3, 4. And so our calculated number is 1.4700 square meters, but our multiplied numbers, 2.10 has 3 significant figures, 0.70 has 2, so our answer needs to be to 2. 1, 2. The third digit is a 7, which makes that round up to 1.5 square meters. The third calculation to do here is 2.5426 meters divided by 8.4. So this is a division. It's still going to follow the same rules for multiplication in terms of how many significant figures the answer will be to. So if you're writing that out, you get 2.4526 meters divided by 8.4. Now I'm going to do the longhand here Certainly I wouldn't suggest that you do it, but I do want to show, the right way to do it, how to get the right answer in some senses. But you have 8.4 over there. The standard way of doing that is to make it 84. And since I moved the decimal place once over for that number, I have to do the same over here, 24.526. I'm not going to worry about the meters right now. But how many times does 84 go into 24? 0. You write the decimal there then. How many times does 84 go into 245? It goes into it, well, let's see. Does it go into it 3 times? Because 8 times 3 is 24. No, you have 252 there. So 84 times 2 is 168. 245 minus 168 is 77. Bring down a 2. How many times does 84 go into 77? Let's just see if it goes into it 9 times. Because 8 times 9 is 72. 4 times 9 is 36. 8 times 9 is 72 plus 3 is 756. So it goes into that 9 times. 772 minus 756 is 16. Bring down a 6. You have 166. Okay, now if you compare that to this, you can see that 84 is going to go into 166 only 1 time. And you get, oops, wrong. What am I thinking? 84. All right, there you go. Now, the answer has to be to 2 significant figures because 8.4 only has 2. So here's 1 and 2. There's our 3rd significant figure. We don't need to go any further. And so since it's a 1, your answer is going to be 0.29. And the units will be meters because there are no meters over here. This one has meters. Meters divided by nothing are still meters. So this is your answer. 0.29 meters. Think about it this way. If I say 3 divided by nothing, you might think 3 divided by 0 and realize you can't divide by 0, so it doesn't exist. So you might put does not exist or indeterminate or whatever for that answer. The reality is this is saying I'm taking a measurement in meters and not splitting it up. Dividing 2 numbers together is splitting them apart. And by dividing by a number that does not have a unit, you're not splitting it apart in the unit itself, so it stays there.